Alright everyone, so this is chapter 3, and this chapter really is going to focus on kind of just reviewing what water is, what its properties are, and how that's all connected to biological systems. So remember that water is incredibly important for supporting all of life. Alright, most organisms are made primarily of water in terms of their chemistry, their makeup. We live in an environment that is completely dominated by water. We require water more than any other substance, and because of all that, this really is a supporting molecule to all of life. If you think back to evolution, when we were talking about early Earth and the conditions that finally set us up to even get life to start, this was all happening in the oceans. When we look at chemical reactions that are involved in living organisms, water is going to be incredibly important to the vast majority of those chemical reactions. And water in and of itself is kind of unique on Earth in that it's one of the only common substances we see on Earth that actually exists in all three states as a solid, a liquid, and a gas. So if we remember its molecule shape, right, water is H2O chemically, so two hydrogens are joined to an oxygen. Each of those hydrogens is joined to that oxygen molecule by a covalent bond, and we're sharing a single pair of electrons between that hydrogen and that oxygen, so that's why we call this a single covalent bond. Same goes on the other side with the other hydrogen to the oxygen. Now, water is a polar molecule, so although we're talking covalent bonding, we're talking about sharing electrons, that oxygen molecule, that oxygen atom is much more electronegative compared to those hydrogens attached. And so oxygen is going to hang on to those electrons more of the time than hydrogen is going to be able to. So we're going to have this unequal sharing, hence the polar molecule. That's also where we get water's sort of V shape. So because those electrons are spending more time around that oxygen, the charge on your hydrogens is going to be less of a big deal, and so those hydrogens are going to be able to actually sit a little closer to each other, and that's where we get that bent shape or that V shape from. And that's going to be what then ultimately allows water molecules to hydrogen bond to each other. Okay, so remember that with that hydrogen bond, here's that hydrogen bond between two molecules. Hydrogen doesn't have those electrons as often, so we get that slight positive. Remember, that's what that sigma symbol stands for, a slight positive, not a full one. Okay, and your oxygen's hanging on to those electrons more, so electrons are negative. They're going to spend a little more time here. They're going to unbalance the positive in oxygen's nucleus, and so that's where the slight negative comes from. So hydrogen is an intermolecular attraction between two polar molecules, so long as one of those molecules contains hydrogen. And in this case, we're talking about those hydrogen bonds between water molecules, and so there's a hydrogen involved in that. And ultimately, it's going to be these hydrogen bonds that are going to be the reason for all of the properties that are useful to life that we're going to talk about a little later.